Okay, today we are talking about reading scales. And if we look at our objective is to record data that reflects the precision of the instrument that we are using to collect that data. And these first two here are a perfect example of the concept that we're trying to understand. We have two different scales, and this could apply to any scale. So these are maybe scales for length. It could be a meter stick, a graduated cylinder, anything that has lines that designate a measurement. And again, the concept is we want to record data that reflects the precision of the instrument. If we think back to our example of accuracy versus precision, accuracy is how close it is to a set value. So if I say it's 10 centimeters is a set value. And then precision is the ability of an instrument to repeat that measurement over and over and over again. So that every time I measure that same line, for example, it is going to be the exact same measurement. So that is precision versus accuracy. And we are recording data that reflects the precision of our instrument. So if I look at these two scales, number 1 and number 2, I see that I have two different scales. They are for the same thing, and they represent the same measurement. So we have 6, 7, 8, 9, 10. Let's say we're talking about centimeters. And the line is in the exact same place for each. But we can see that those scales have different markings. This scale down here has a marking in the 10th position. This scale up here only has a marking in the 1's position. So when I record my data, I want my data to reflect that. So when I look at my measurement, I have an idea of what that tool looks like. So the way I'm going to do that is I am going to write down the digits that I know for sure. A digit that I know for sure is anything that I have a marking for. So I have a marking in the 1's position, and this line here, the arrow, is not quite to 9, so it's in the 8. So I'm going to write 8 point, and then I'm going to make one guess. So there is not a marking in the 10th position. So I will guess that to be 8.9. And if I count my number of significant figures, that's 1 in the 1's position and 1 in the 10th position. So there are two significant figures. If I look at the scale for number 2, again, it's the exact same measurement, but my instrument is different. So I want to record data that reflects the precision of my instrument. So I'm going to go through the same exact process as I said before. I'm going to write down all the digits that I know for sure. So I know the 1's position, 8, and point. I know the 10th position for sure because I've got a marking for it right there. Right? So I know 8.9 for sure, and then I'm going to make a guess. So I'm going to look at where those two things fall, or where that line falls in between those two, and I'll say it's about halfway in between. So 8.95. And this one has 3 significant figures. So again, the idea is that I am going to record data. So in this one, the data I recorded was 8.9, and it had 2 significant figures. And in this example, for this instrument, I recorded 8.95, which had 3 significant figures. So I should be able to tell or know that the second instrument was more precise than the first. So if I think back to what the essential question is, how can we record data that reflects the precision of the instrument? And it's done by writing down the digit for everything that you know for sure, because you have a marking for it, and then one